So hello and welcome friends to our channel Intromech, and here we discuss about basic mechanical engineering concepts. So guys, as we have started our new series and we are discussing about different topics with the help of Solidworks and its simple simulation. Now today's topic is very interesting, which is like design optimization. So whenever you design something, you cannot be sure that you have utilized the material strength completely. The meaning is, let's say if you have designed something and it has so and so dimensions, you cannot say that the dimensions are perfect. Can someone reduce the dimensions and still your objective can be satisfied? It may happen, and it will cost less and it will be effective. So our today's topic is based on the same thing, that is nothing but design optimization. So in our channel we discuss about many types of such different industrial topics. So if you want more such kind of topics, please subscribe the channel and hit the bell icon so that you will get notified when some new content come on the channel. So without wasting time, let's get started. So let's first see what is the design optimization methodology. So when we start something, we identify some design objectives like say variables and constraints. So whenever we design something, we can have some variables and we can have some constraints. The meaning, if say we have some rectangular part, my variables can be its breadth and height, and constraints can be my breadth should be lesser than say 100 mm and height should be say less than 50 mm. So these are my constraints depending on say the material availability, the cost, weight, space constraint, whatever it may be, right? So first we do the estimate the initial design. So first we design the initial thing, we perform the analysis, then we check the constraints. So if the design satisfy our constraints, we end, or else what we do, we update the design using the optimization scheme, we change the variables and other things, and again the loop is continue until we get satisfactory results. So here you could see this was my original design, right? The original, we do some analysis over here. What we did is we have topology optimization, that means we applied some variables and constraints. So what we have got here, like we can reduce some material, then we again optimize our design, and then we finally did the validation with the help of analysis. So my initial design was this and my final design was this. So you could see the difference over here. So let's see one example. Now here you could see one hexagonal bar we have, and let's say it is going to be used as a support. So there will be some compressive load which is coming on the rod, right? So let's go to the simulation express, and what we have fixed the bottom face and there is a load coming on the upper face, let's say 10,000 Newton load which is coming on the body, right? So the stress you could see 4.07 into 10 raised to 6, and that is the maximum stress which is coming. And on the whole body you could see the displacement, the maximum we are getting like 1.38 into 10 raised to minus 2, that is 0.013, right? And we can see here the maximum stress is coming like 4.07 into 10 raised to 6, right? Now we know the maximum stresses which are coming in the body. So how we can optimize? Let's see. Now hit the next. Now what we have here is optimize. So as soon as you hit optimize, it will ask, do you want to optimize? Yes. Then hit the next button. Now here it will ask for the parameters. Now what parameters we have is like we have height and the size of the hexagon. You could see now we have selected the size of the hexagon. The model dimension 60 got selected and hit OK button. Now you could see the variable. Now my variable is the diameter and what range we have 30 mm to 90 mm. So you can change this according to your space concern. Now what we have done, we have changed the range from 30 mm minimum to maximum 120 mm. So these are my variables. Now what constraint I have, you can add other dimensions also. We are going to stick to only one dimension only. Now what criteria? Factor of safety, maximum displacement, maximum stress. So let's check the maximum stress over here, and we have seen the maximum stress which is 4.07 into 10 raised to 6. Now I want the maximum stress in the body as only say 3.07 into 10 raised to 6. So I have reduced the maximum stress coming in the body, right? So let's see now how it goes. Now hit the next button and run the optimization. So it will carry some processes. You could see the dimension, the size of the bar is getting changed, and what was the initial value and what is the optimal value over here, right? So the initial value was say 60 mm and the optimal value which I have got is, say it is around 75 mm. So the stress in the body we have reduced, so we have to increase the size. So which dimension would you like to use, initial value or say up to optimal value, it is asking. So we will go with the optimal value. Now we know that we have reduced the stress in the requirement, right? We have reduced the stress, so it has given the results. Now uh, we could see the mass has also been increased, right? The dia has also increased. So if you want to reduce the stress, definitely you have to add some more material, and that's why the size has gone increased. So instead of carrying multiple calculation, you have got directly that if you go with 75 mm say size of the bar, the stress will get reduced, but at the cost of what? The increased mass. You can see the mass has increased by almost 1.5 kg. So you have to take into consideration this thing also, because the cost now has got increased. So optimization is always the thing. If you reduce something, some other thing will get increased, and that's why you have to find some optimized solution, right? Now let's do some other optimization. Now our final bar has got modified to 75 mm size, right? So here you have seen that how this optimization tool can be effectively used. Like you don't have to carry multiple iterations, multiple calculations, but the software is directly giving you the value. So this is how you can utilize the optimization tool in the software for designing different kind of objects. So this is it for the today's session. I hope you liked the session, and if you have any doubts, please do write into the comment section and we can discuss over there. Until then, stay home, stay happy. Thank you for the patient listening. Thank you.